My name is Juan Gonzalez. I'm a geologist by training. I'm part of the College of Sciences at the University of Texas, Rio Grande Valley. I am with the Environmental Sciences program, and I now consider myself a South Texan. I've been here for going into 13 years now. So I'm very happy and fortunate to be here and to live here. As far as my research interests, well, I'm interested in Earth's history in general, but particularly in the last 2 billion years of Earth's history that have seen amazing environmental changes from sea level rise and global warming and the appearance of Homo sapiens and the the interactions Homo sapiens have had with the environment. All of those interest me. My talk today is about a little bit of that. It's a little bit about geoarchaeology, and it's mostly about a major geologic event that shaped the valley. If you've been to any of these talks before, well, it's going to be a lot of the same, but if you haven't, hopefully this will be new and you learn something about our geology and our own background here, not far from where we are. So my title is New Insights into the Geologic History of the Lower Rio Grande Valley, and by that I mean, by new insights is my own take on how I see and how I understand some of the things that have happened as an outsider, because I came here with fresh eyes, hoping to learn and contribute to the geology of the area. So I know we have this technical issue with the sound, at least on my end, where I don't hear you, but please do ask questions as we go. I don't mind at all. In fact, that will be my preference if you are asking questions and somehow through Barbara and Robert, we communicate here and I manage to ask. That would be my preference. I will also be happy to answer any questions at the end. Okay? So I want to start by acknowledging my collaborators. This is nobody really works on isolation anymore. What I'm about to present here is collaborations with colleagues in my own department and college, with other colleges at the university, with people from other schools, right? UCLA, Houston, the Smithsonian, and with the help of an army of students. And I'm only acknowledging a few of them here, but there are many, many more. All right, so the first question I want to ask is a trivia question, and let's see if we get through this. Does anybody in the audience know what is the state of Texas rock? No? I see some heads moving, indicating no. Anybody? No? All right.
Somebody suggested the Jefferson-Davis rock.
Jefferson-Davis rock. Yeah. Oh, I saw that, but I'm not even sure what that is. Let me make it easy for you, and I will answer this. So the Texas state rock is petrified palm, and there is a lot of it in our area. It is highly appreciated and valued by collectors. It is informally known as palmoxylon, and effectively what it is palm trees that were preserved in the rock record that were preserved, and now they are beautiful and they show all of that texture that you see there. The next question, which is very much complementary to this one, is what is the Louisiana state fossil? Anybody? No. Rolando, I have seen this. Okay. The answer, you will be surprised, is petrified palm, palmoxylon. So petrified palm is the state rock in one state and is the state fossil in the neighboring state. And there has to be a connection between these two. And the reason for that is this major geologic event that I'm about to present to you that helped shape the landscape as we know it, that probably changed climate and life as we know it, and is really is really a major geologic event that occurred for all purposes in an instant in geologic time. Okay, so when I moved here, I on my own started kind of exploring, and I found this house in Roma that is right there by Highway 83, and the whole fence of the house is built out of petrified tree trunks. That's a person for a scale, right? And right across the street from it, there is that church. I forgot what the name of the church is in Roma, but the entire fence of the church is built out of petrified wood. And these are just two examples. The point I want to make is there is a lot of petrified wood here in South Texas. And when I arrived here in 2009, I started reviewing the literature and papers and old papers. I came across the idea of there was a suggestion for a petrified forest in the Starr County. So based on all the pictures I'm showing you and all the evidence that I have observed over the years, quite likely there was a petrified forest here, and this ties very much into the previous two questions that I asked you. All right. The other thing that I did when shortly after arriving is I got very interested in projectile points. The best evidence for human occupation of the lower Rio Grande Valley, or the Rio Grande Valley in general, comes in the form of lithic artifacts, projectile points. And I had access to museum collections and to some personal private collections that were very well kept and curated. And, by, looking at those very early, I noticed that a number of those points were made out of petrified wood. In fact, every point that you're seeing here on this picture is made out of petrified wood, but some are even made of petrified palm, such as this, with all the little dots there, which are those internal cells that move nutrients and water to the tree trunk and palms, as well as this one and this one. So the point is, yeah, there is a lot of petrified wood in the area. Petrified palm is the state rock. And back in prehistory, humans were using this resource to make their stone tools, and this caught my eye, okay? Very much part of the story and complementary to this notion of lithic artifacts is the fact that when you look at geologic maps in the area, there is, or over the last 50 or 70 years, there's been some uranium mining that started back in the 40s and 50s. And each one of those symbols here indicates an uranium mine. Now, what I found all about that is not the uranium, but it's the fact that it occurs in those sedimentary rocks, in those sedimentary units. The yellow there are quaternary sediments, kind of undifferentiated, not lithified. The Goliath Formation that you will be hearing more about here in a little while has a lot of those mines. So it was very strange to me that you will find uranium in this type of sedimentary environment in Texas. There has to be a source for that uranium, and that kind of piqued my interest. So the whole story really starts about 28 million years ago. This is a map that shows the paleogeography of the Gulf Coast, and the paleogeography is really the ancient geography of an area. So I'm showing here you North America, and if you pay close attention, it doesn't quite look like it does today. For instance, the Florida Peninsula and a lot of this portion of the eastern seaboard that is not there yet. That tiny line right there is where the shoreline is today, right? For instance, here up on the north, Greenland is still attached to North America. Hudson Bay is exposed above water, and North America is really connected to Asia 28 million years ago. Okay, so I'm trying to paint a picture for you of what the geography of not just North America, but our part of the world looked back then in the Oligocene, again, roughly 28 million years ago. Back then, the shoreline of the Gulf of Mexico, this is hard to see here, I fully realize that, but the shoreline was not what it is today, but it was basically in the Star County. Okay, and eastward from that position, so from say Rio Grande City, all the way to Brownsville, those rocks and sediments have not been deposited. That back in the day would have been deep water Gulf of Mexico. Okay, very different geography, very different world, and I need to position this and paint this picture for you because of what happened around that time. It's a geologic event that really changed the landscape and is responsible for all the petrified palm, petrified wood, and other rocks that I'm about to talk about. So that event is basically a major ash fall, a volcanic ash fall. This was a live landscape and climate changing event, and I don't really have good modern day pictures to show you what happened, but this changed the landscape for good. I have here those insert pictures are kind of showing a coastal setting with palm trees. Same thing here, and a lot of us fell in the area and buried the landscape completely. Everything was buried by several millions of ash. And for all purpose, as best as you can tell, and I hope I can convince you of this here in the next few minutes, this happened in a geologic instant. By that I mean few weeks to maybe a couple of months in geologic time. That's basically an instant, and it changed the landscape forever. So we are back, again, to refresh your memory, we are back 28 million years ago, and we have this major eruption, produced eruption. I'm not telling you where yet, but we have the ash falling in the area, okay? So this picture, to be clear, doesn't do justice to what happened. It was orders of magnitude larger than what I'm showing you here. The days were probably covered by ash, you know, one day after the other, and this went on for several weeks to maybe a couple of months, okay? And I don't want you to visualize this as your typical Mount St. Helens 1980 eruption that we are all somewhat familiar with. This happened already 40 something years ago. That was a very modest or very small volcanic eruption in terms of the ash volume it produced. Here, this lower plot compares that eruption with other very well-known volcanic eruptions that have been recognized in the rock record, and they left layers of ash worldwide. So this eruption here, this is Mount St. Helens 1980, only produced about a quarter of a cubic mile of volcanic ash. That is very small, right? Another well-known eruption in historic times is Mount Krakatoa that produced that 4 cubic kilometers of ash, or miles of ash, that is, in 1883. And then by the time you get here, you get to some really huge volcanic eruptions. The Yellowstone Caldera, the first Yellowstone Caldera eruption that produced 60 cubic miles of ash. Really something that is hard to comprehend. And the second and third Yellowstone Caldera eruptions are much smaller. Okay, let me see if this stop sharing and I show you. I'm sure you all have seen the recent Tonga eruption, right? Stop sharing. I'm not going to let this go on for very long, but this is something that happened in the last 2 weeks. And in my mind, it's one of the largest volcanic eruptions that has taken place in my time as far as the amount of energy released. And I won't only let this run for a few seconds. So this happened on January 15, I think it were almost not even 2 weeks ago. it basically blew the top of the island completely. The caldera produced a series of earthquakes that triggered tsunamis and whatnot. So here it is again. You might have seen footage of this, but I'm only bringing it to the talk because it's very recent and you might have seen it, okay? So with that, let me go back to my PowerPoint. So I bring Mountain Helens into the discussion here because you might have seen footage or videos of that eruption. It is nothing in comparison to what happened here in the valley 28 million years ago. Just keep in mind, because none of the pictures of the footage I can show you is even comparable. This is thousands of times larger than even the biggest volcanic eruption, okay? And the evidence for this is basically or most clearly seen on this outcrop in Rio Grande City. This is right next to a major highway. And what you are seeing here is 17 meters of ash exposed above road level, right there. This is the street level. This is a person for the scale. All of that white stuff and even the light brown or red stuff here is volcanic ash that has turned into a soil. That represents a single event, and you have 17 meters of it exposed above the street level. We wanted to know how much of it was below our feet. So we ran a radar, ground penetrating radar, right there by the street, and everything that you see here on this black band, which represents 3 more meters, is basically the continuation of that ash below our feet or below the street, the pavement there, until you find this next layer, shown here by the red and orange and yellow lines, that represents the next geologic unit below, right? Below this. So this ash fell in a geologic instant. Again, it changed the landscape. Everything was buried, and it occurred in a very short period of time, right? It represents, by the time you add what is below ground and above ground, it represents full 20 meters. And I suspect that it was actually thicker because the top of it has been eroded. I will show you pictures of that. So this event, this ash, is responsible for the petrified forest, the petrified palm, and the uranium. This is the source of the uranium that we mine here in South Texas. The uranium is not produced naturally in sedimentary rocks like I show you on that map, but rather it is associated to an igneous event, something like this. Okay, so this brought the uranium with it from the Earth's mantle, and it was transported into the atmosphere. It traveled some distance, and ultimately it fell in this area, and it produced a package that is about 20 meters thick. What I'm going to do next is show you pictures of the top of the ash as well as the bottom of the ash to see the upper and lower contact. Okay, so here we are. This is an outcrop not far from the other one. Again, this is Rio Grande City. Highway, Interstate Highway 83 is right there. It's very wide and reflective, right? This is a picture from a field trip from one of our classes. Those are the students looking for quartz crystals and other things that you can find in there. And you notice that it's just basically, at least in the top 3 or 4 meters that you're seeing in this picture, is all uninterrupted ash. There is no layering in between, no soils, no vegetation, right? Now, on top of the ash, you have this Goliath Formation. The Goliath Formation here in South Texas is represented by a sandstone or a gravel unit, a conglomerate, and that's what this is. And back when this picture was taken in 2012 or 14, somewhere around there, we didn't really know the exact age of the ash. I mean, we suspected it was in the order of 25 to 30 million years because of the association with other rocks, right? But the exact age, the absolute age that we want to know in geology, because again, this represents a good marker, was not known. So that red arrow points at the top of the ash, and right at the top of the ash, below, above the ash and below the gravel is I'm sorry, I had a little thing to show you there, but it's not doing it. What I wanted to show you is that you can put your finger on that line, that erosional surface, which is what I call here the top of the ash. And because we dated the ash now, and we know it is 27.2 million years, and we know that the Goliath Formation is between 5 and 50 million years, no one really knows for sure. We have a gap in time represented by that surface right there. It's an erosional surface. We call that an unconformity, where we have roughly 15 to 20 million years of rock record missing that were eroding and are not there. So this is the top of the ash. The bottom of the ash looks like this. This is Arroyo Los Olmos. Highway 83 is right there. There's the power line, not far from the previous two pictures. This here is the bottom of the ash, and the contact with the underlying unit, which is this Frio formation, this red unit, occurs behind those trees right there. So this vertical cliff here is the bottom of the ash, which is not as white because it's mixed with clays, right? And it rests on top of this red unit that is called the Frio Formation, which is marine in origin, right? So to summarize it, we have this package of volcanic ash that represents, for all we know, a single event, and it's 20 meters thick. Now you have seen the top, and you have seen the bottom, or close to it. The bottom really is behind the trees, but you know what it looks like. It's very much like this, right? Let me show you the extent, the geographic, the aerial extent of this ash, because it's pretty massive, okay? This is why I argue it's not Mount St. Helens. So bear with me here. North is to the left, not to the top. The pictures I just showed you are right there in Rio Grande City. This is the Rio Grande here. This is Falcon Dam, okay? So if you move 60 miles north of Rio Grande City to James Hop County right here, I'm going to show you a picture of what the ash looks like right there. And then if you move another 180 kilometers to Three Rivers, I'm going to show you another picture right there. These white lines are basically the lower and upper contact of the ash. I'm trying to map the ash for you so you can help your eyes see it, right? Anything between those two white lines is the ash. You have seen pictures of it right here, top and bottom. The next picture is here, 60 miles or 100 kilometers to the north. And then the picture after that is an outcrop of the ash here in Three Rivers. So here it is. That's the ash right there, all the way to the top of that hill where the wind turbines are. This is Jim Hall, right? And here is the lower contact. Here is that where the ash is kind of mixed with that red clay. This red clay again is the Frio Formation, right? So what we know is that at the time this ash fell, this area and Rio Grande City were really close to the shoreline. The shoreline could not have been very far away. And the evidence for that comes, well, from the petrified ponds for sure, but also for a number of microfossils that we find in that red clay that suggest it's a shallow marine environment, something like a coastal lagoon or so on. This is the other outcrop that is 180 kilometers north of the previous one in James Harbor. And here, right by the highway, it's 7 meters thick above ground, and it's at least another 7 below ground that we have been able to see. So next time you travel to San Antonio, if you stop at the rest area there on the highway, that rest area is built on the ash. And if you take a short walk around the rest area, you'll see the white soils that are associated to this, okay? So the point is, not only this is a very thick event, but think about it. It's pretty extensive, right? And I'm trying to paint a picture here where a lot of that ash fell in our area. South of the river, we have not been able to go there for safety reasons, and because of university discourages us to go there at this time. But using satellite images and Google Earth images and whatnot, we are able to trace the ash another 60 kilometers south. So this was a major geologic event. I don't need to, say more, right? Here is the Catahoula Formation, not just the ash, but the Catahoula Formation, which includes the volcanic ash and other sediments. It's a much thicker unit, and the volcanic ash is part of it. These are the microfossils that we have found in the underlying Frio Formation that suggest it was a shallow marine environment. Now, if you look at the unit here, that gray, that dark gray or bluish unit right there, that's the Catahoula Formation, which, if you think about it, it kind of parallels the shoreline, okay? So again, back at the time of the position of this ash, right here in Stark County, all of this was deepwater Gulf of Mexico. None of these rocks have been deposited yet, right? The shoreline was kind of where the edge of this unit is, okay? Here is a little more detailed map. The unit I'm talking about is the Catahoula Formation, which is 900 to 1,800 meters in thickness, and is this red unit here, right? It parallels the shoreline. That would have been the shoreline. Then, by the time you move into Louisiana, they change colors on us, but it's this purple unit. And by the time you go into Mississippi and Alabama, it continues there, right? Now, to be clear, all along the Gulf Coast, the Catahoula Formation has ashy layers. It's mixed ash with other sediments, but it's here in South Texas where it is most striking. The amount or the volume of ash is most striking, and it has that amazing outcrop of a single event representing at least 20 meters of ash. Now, when you look at the subsurface, all of those strata basically parallel the shoreline. You can see it there, right? And as you go westward or northward here, they get progressively older. In other words, this is the barrier island with the sands. That's our sediments that are accumulating there today. And by the time you start moving westward into Stark County, you suddenly get to 28 million year old rock, okay? Now in the subsurface, all of these units, and they are here, so this is the shoreline right here. This here is somewhere out there in the Stark County or Stark and Zapata, just around Roma. All of these units are not flat and horizontal. They have a tilt. They are tilted towards the Gulf, and that's what this cross-section is showing, right? Now, this is important because if the units were like a layer cake, flat and horizontal, you would go from Brownsville to Roma and you see the same rock all along. But it's the fact that we have the tilt that starts showing all the units as you move farther west, okay? So you already know about the ash. You already know it's part of the Catahoula Formation. Let's see what else kind of is associated to it. And it's part of what piqued my interest when I first moved here. These are scanning electron images of volcanic ash, not just our ash, but volcanic ash in general. I just want to show it's very rugged, it's very sharp and very abrasive, right? And this here is 30 microns across. For reference, a human hair is about 20 microns. So these are very tiny volcanic ash fragments, okay? Now, one of the things that we did is we precisely dated the ash. Again, we used to take students there and tell them, well, we suspect this is in the order of 25 to 30 million years, somewhere in that range, but we needed to confirm that. So what we did is we took a sample of the ash from that outcrop, and by sieving them, we extracted these crystals that you see here or here. These are zircon crystals. These crystals are produced in the magma chamber at the moment of the eruption. When the magma is kind of quenching and is solidifying and great pressures build in the magma chamber and it blows stuff off, it sends all of that ash, and with the ash, it sends zircons. Now, the importance of zircons is that they are very resistant, whereas every other mineral in the ash, or most minerals, I should say, alter chemically to clays and other weird things, the zircons remain unaltered. And we can collect zircons, we can measure the ratio of uranium and lead, and by knowing that ratio, we can obtain an age. And this is precisely what we did. We sent samples to 2 different labs, and we got very remarkable and consistent ages, right? So you have the lead uranium ratio here, lead 206 to uranium 238, lead 207 to uranium 235 here. This line here with the dots is called the Concordia line, that is a theoretical line. And each one of those ellipses represents a measurement. Where most of the ellipses overlap, which is right here, is where we get the age. So that's 30 million years, 29, 28. Our ash is 27.2 million years. So this is a major geologic event that occurred back then, and now we have absolute ages for it. It's 27 million years, consistent with the age of the Catahoula Formation that is Oligocene in age. But now we have these really good markers. So if you go to the Three River Outcrop or to the Jim Hog Outcrop, you know you are standing in rocks or sediments or volcanic ash that is 27 million years old. Okay? Are there any questions at this point? I know I've been doing a lot of talking. Good. That's a totally valid question. Let me see. I mean, I can speculate on that, and I will. We don't know for sure. The short answer is we don't know for sure, but we have good candidates, okay? So with that age now, here's where the slide is. With that age, we know that the volcanic ash, right? 27.2, the Goliath Formation is 5 to 15. And then this is the unconformity that I was mentioning earlier, where we have in a single line, we have anywhere between 22 and 15 million years of rock record missing. We have a gap. That's one of the things that we learned from dating the ash. Okay, I will get to the question of where it came from here in a minute. We ran some X-ray diffraction to classify and characterize the mineralogy of the ash, and we look at these peaks, right? So these are counts on the y-axis, and these are 2 theta peaks. So each one of these peaks represents a mineral. What is very striking on this ash is this peak that represents the mineral quartz, and this tiny peak here that represents feldspar. The calcite is the caliche that we have here in South Texas that is everywhere in these arid climates because, as you well know, we have more evaporation than rain. And when that is the case, groundwater moves to the surface to replace that evaporating water, and it brings ions, and you end up forming very thick caliche layers. That's what this peak is. Now, why is this X-ray diffraction analysis important, and why is it having so much quartz and feldspar important? Is because, as the color of the ash indicates, those very white ashes are very explosive. They don't give you volcanic eruptions like you see in Kilauea, for instance, or in Iceland, where you see rivers of lava flowing the flanks of the volcano. These lavas are very viscous, these lavas that have so much quartz and feldspar. So instead of flowing, because they are relatively cool temperature-wise, they accumulate pressure, and when enough pressure accumulates, the caldera blows its top off violently and produces a major volcanic eruption, such as the one in Tonga, or even Mount St. Helens at a much smaller scale, or our own Catahoula. So keep in mind that this light color magmas are very explosive. You never see light colored magmas flowing with molten rock like you see in Hawaii, okay? They are very viscous and they basically just explode and produce clouds of ash. To answer your question, where did the ash come from? Well, so we are here in Stark County, right? We look at a data set of volcanic eruptions and volcanic ashes that have been dated. This data resides in the Smithsonian and in various other locations. So we look for chemical affinity, ashes that look very similar to ours. And I didn't show you this, but we also ran chemical analysis on the entire 20 meters. And it's very consistent. The geochemistry of rare earth elements doesn't change from bottom to top. So we look at that chemical composition of the ash, and we also look at the age, because now we know this is a caldera that exploded 27 million years ago. Now, it turns out that this part of the Sierra Madre here, this is the Sierra Madre Occidental in Mexico, back then was very active in terms of tectonic. A lot of subduction was going on, and there are a number of calderas in that portion of Mexico, indicated here by the black dots. So those are calderas that erupted between 27 and 35 million years ago. That's what MAA means, right? So we don't have one candidate, we have several candidates, or actually many. Every black dot there is a possibility, because they all have roughly the same age and very much the same composition. So we suspect it came from the Sierra Madre Occidental, right? That's what this means. Sierra Madre Occidental, SMO. There are other options from calderas in New Mexico, but the wind pattern doesn't fit, right? They are roughly the same composition and similar age, but we think this is a better fit. So the eruption occurs, the ash is thrown into the atmosphere, the prevailing winds transported to the east, and it falls in our area and forms that very thick deposit that is right next to a major highway that realistically no one had really looked at until we did. You look at the roadside geology of Texas, the book that I travel with in my car when I go around Texas, and this major outcrop that is clear to anyone with minor training is a volcanic ash. They describe it as a sandstone, to give you an idea. So we made some progress on that way. We published a couple of papers, and we're giving a number of talks at meetings, and we have other things going on with the ash, and I will share with those with you at some point in another time. So this is the Sierra Madre Occidental. It is part of what is considered large igneous provinces of the world. Now, just notice that there are only 3 areas in yellow. Here in South America, in the Antarctic Peninsula, and here in Northeast Australia. Those are silicic large igneous provinces, and the significance of those is that they produce very eruptive magmas. The blue and the red here is different type of magmas. They don't fit the geochemistry, but the yellow does. So the Sierra Madre Occidental is in the map of large igneous provinces because it was a major geologic event with no one but dozens of calderas that were pretty much doing the same thing. All right. I think I'm about to switch gears here into another topic somewhat related. Are there any questions at this point?
Yes, I think you help answer this next question. Can you also use the zircons for source estimation?
Very good question. With a lot of work, with a lot of detail and hard work and expensive work, you could probably do trace element geochemistry on the zircons and tie them to a more restricted area. Short answer to your question is, with a lot of expensive work, you could. We are not really moving in that direction because we have other things that are more practical to answer other questions. but it's doable using the zircons, okay? Any other? Okay, so I'm going to move on to another component of this talk that is very much tied to the same thing. One of the things that I observed when I started looking at those collections of arrowheads was a very distinctive rock that had these colorations that were unusual. It didn't feel like any of the local gravels and any of the gravel units. And by talking to collectors and other experts, avocational archaeologists and others, it turns out that this rock that you see here, these points are all made of that rock. This is from a paper that we published in 2014, is known as El Saus chert. I have this asterisk here to remind me that I should describe or define what chert is for you. Chert is a sedimentary rock composed of fine-grained silica. It's very resistant. It's the prime material back in prehistory, not just in South Texas, but worldwide for making projectile points and arrowheads because of its knapping properties. It gives very sharp edges. And El Saus because of where it is found. So it turns out that when I started asking people what they knew about it, it had been known for over 50 years in archaeological collections, but few people knew anything about it or where it came from exactly, right? It turns out that by looking at collections, this is back in 2014, the oldest points made from it date back to the early Archaic, which is a time period between 6,000 and 4,000 years ago. And that is this point right here. This is the very famous Hidalgo Point that is Middle Archaic, and so is this guy here, right? So the oldest points made from El Saus chert date back to possibly 6,000 to 4,000 years ago, which suggests that Native Americans or early inhabitants of the Rio Grande Valley were going around looking for lithic resources to make their stone tools, okay? You might be wondering, why do we suddenly switch from volcanic ash to El Saus chert? And that question will be answered here in a minute. So here is the ash outcrop that I showed you earlier. This is the main highway 83, right? Los Olmos Creek, Rio Grande City. This red dot is where we found the outcrop in Stark County of El Saus chert, which is due north of the ash, of the outcrop, ash outcrop that I show you, about 15 or 17 miles due north, okay? The white lines that you see there are those limits of the ash that I showed you in an earlier slide. So much to my surprise, and I didn't know this when I started working on the El Saus chert. El Saus chert is genetically associated to the volcanic ash. And to my knowledge, there aren't many outcrops of it. It's just that outcrop in Stark County. So this presents a unique opportunity to study dispersal of points. Points made from it, we want to see how they were being exchanged and how they travel and where they are found. So I embarked on a project to characterize this rock. So I contact the owner, Mr. Villarreal here. This is Federico, a former student and a good friend, and archaeologist Nick Morales. So this is what the outcrop looks like. This is the actual rock. Very rugged. From the distance, it looks like that little hill. There's not much to it. And in detail, all these rocks that you see here broken are flakes and parts of rock that were left there by early inhabitants, right? And these darker colored rocks are the rock hammers that they were using to break the rock at the outcrop. So clearly, Native Americans were visiting this outcrop of El Saus when we started this as early as 6,000 years ago, right? So we became very interested on characterizing the outcrop. It is not very impressive. It's basically about 50 meters across by 5 to 7 meters thick. It rests on the ash. This orange unit is the ash. And what we think will happen is groundwater remove the silica from the ash, and it redeposited as chert in this pink unit, because there is evidence of springs occurring in the area. That's what these wavy blue lines represent. So I'm making it kind of simple because I don't really understand how it works, but we went from ash to chert by groundwater. Groundwater dissolves the silica and it reprecipitates it somewhere down, farther down the path of the water as chert. Okay? We found that it fluoresces. You expose it to ultraviolet light, and it fluoresces, and it's due to the presence of uranium minerals. So this yellow-green fluorescence is associated to uranium oxide minerals, one of the properties of El Sauz. Under the microscope, it has some very weird and peculiar textures, such as this one here. We call this the Woodpecker Feather because it's kind of how it looks, right? This is under polarized light under a petrographic microscope, and everything that you see on that picture is silica. This has a magnification of about 40 times when the picture was taken. Okay, so we look at it under scanning electron microscope under high magnification. This is about 11,000 times, and we find some very odd looking things. We are just approaching the study of this Sauz chert from various angles. Okay, and then we embark on a project to find a geochemical fingerprint to be able to tell whether the projectile point is made from it or not. So the instrument we use is this here. This is an X-ray fluorescence equipment. It basically produces an X-ray. You shoot or you aim it at a sample. The X-ray bounces back and the detector traps that energy. And it basically tells you the composition of your rock. This can be used with metal alloys, with man-made substances, right? We happen to be using the X-ray fluorescence here for the study of chert. So what we did, is we collected some samples at the outcrop, every one that you see here, so we know where they came from. We analyzed them with the X-ray fluorescence, and one thing that was very striking to us is that every single piece has a zircon peak. This is the spectra, right? The spectra that produces that the X-ray fluorescence produces, and it also has this much smaller titanium peak. So this was an eye-opener. Every single sample that we measured, and we measured over 250, had zirconium and titanium. This is unusual because zirconium and titanium do not occur in most cherts, okay? So we became very interested in this. Then we actually ran kind of a blind test. We look at various points randomly collected from a collection, right? And we ran them, and these are the outputs, right? So this point here is that one indicated by the star. The other ones are the rest. These are just numbers of some of those rocks, right? I just want to show you that the rocks from the outcrop have high zirconium, and by the time we start measuring these points here, notice the zirconium disappear until we get to that point. Out of this collection, and these are all points, only this one is made of El Sauz. The same thing applies here to the titanium. These are the samples from up here. These are the points, and only that point has high zirconium, high titanium. So this was very encouraging. Then we embarked on a much larger study. We wanted to see how well Sauz chert compares to other cherts. So here we are comparing samples from the outcrop with other chert samples, right? Notice the nice cluster, how tight that is for El Sauz. Every red dot here is El Sauz. Every other dot of different color is various cherts that we collected. The x-axis here is zirconium over rhenium, which is a way of standardizing your measurement. The y-axis is titanium over rhenium. Rhenium is the source of the X-ray. So You can normalize your sample to any element. We happen to choose this. So we became very interested. When you compare El Saus to other Saus, it is distinct, to other churches, it is distinctly different. It's the only one that has high zirconium, high titanium, and they all cluster kind of in this upper right quadrant of this plot. Then we actually put this finding to the test by measuring only projectile points from museum collections that were made from El Saus, right? So this is Museum of South Texas History, one collection that we borrowed from them, Museum of South Texas History number 2, and a collection from Texas State, right? So based on what we saw in the previous plot, I would argue that anything within that circle is made of El Saus, right? Geochemically unique. So this is a useful study because this resource, based on the amount of rocks that were left at the outcrop, was clearly very valuable to early inhabitants, right? And it's tied to the volcanic ash. We wanted to see how important it was to the early inhabitants. So we actually look at nearly 1,000 samples and we characterize them by rock type, right? El Saus chert is shown here in yellow. So considering how restricted the quarry is very remarkable that the full 5% of all points is made from this resource, right? The rest are basically, the bulk of it, are 70% of those are made from gravel cherts found on the river or the gravel formations, right? But 5% were made from El Saus. And then we went further. We wanted to see, we actually kind of by accident, as we were looking at collections, we observed something very remarkable. What this red square here shows is the Golondrinas Point. This is a poster that is put together by the Department of Transport here in Texas, the DOT, and you can request it, they give it to you, right? That shows the Paleo-Indian points that have been found in Texas from 13,000 years all the way to 9,000. I'm highlighting this Golondrina point because as we were running our analysis with museum collections, we found one whole point and two broken ones that happened to be made of El Saus. Why is this significant? Well, it is significant, I would argue, because when I started talking about El Saus, I told you the oldest points were about 6,000 years, right? This point is about 10 to 11,000, which suggests that early people in the Rio Grande Valley were already visiting and mining the outcrop as early as 9, 10, or perhaps even 11,000 years, okay? So this is the geoarchaeology component of this talk, right? All of these points look kind of the same, kind of, pale, white, not very interesting. But geochemically, there are two that are unique, and we only know that because we run X-ray diffraction, X-ray fluorescence on them. Those are the only two made from El Saus, right? So we have a geochemical fingerprint that allows us to tell out of any collection of points, any number, which ones were made from El Saus, okay? All right. So with that, I want to just wrap it up by saying, if you have projectile points, you know where they come from, let us know. We are very interested in studying them, characterizing, photographing them, and we'll return them to you. We're just interested in expanding our knowledge, and this is my contact information or my colleague or the phone number. Also, I want to make you aware of a book that is about to come out that features the volcanic ash and the El Saus chert. This is a project that we call Ancient Landscapes of South Texas, Hiding in Plain Sight. This is a pictorial book. It's just basically a ton of beautiful pictures of geologic and archaeological features in the valley that you won't find anywhere else. It will be available in March. It's about to go on print later this week. So be aware, it's coming. And the other thing you need to be aware is we have these projectile points of the lower Rio Grande Valley that are unique. This, we call it an immersive experience because this poster has augmented reality. You can use your phone and see the points rotate, and you can watch short animations on each one of these periods. Both of these products will be available. This will be free for distribution. The book you will have to purchase, but I want to make you aware of that. There is the Golondrina Point. And here we are back to the outcrop. Okay, I had an animation, but it doesn't want to play. So I'm going to stop sharing. And I want to make myself available if there are any questions.
Is there a new record? Some of these projectile points found?
Not yet. No, not yet. We hope that somebody will come to us with a point that we know where this point comes from, and it turns out to be a very old point that travel long distances. We know that some of the better known lithic resources here in Texas, from the Olivates in North Texas, have traveled into Mexico and Montana and Wyoming. So I would not be a bit surprised if El Sao's traveling to Mexico and farther east and west. It's just a matter of time and being able to find the right point in the collection in a museum somewhere, or have someone say, here, I found this point and I know exactly where it came from. No, we have not. We do know that the original volcanic ash has a lot of zirconium and has a lot of titanium, right? So the genesis of the chert is not surprising, given that the parent material, namely the ash, is there. But we have not tried to run simulations on how you. I mean, for among other reasons, it will take millions of years to replicate this, right? Because you have to remobilize the silica kind of one atom at a time and reprecipitate it somewhere else. So no, we have not done that. Wonderful. That's great. I would love to take a look at it and photograph it and maybe run it the unit and see if we find any south points. That is a spear point, and so is the Hidalgo that I show you. Both the Hidalgo and the Golondrina point are spear points. They are not. Let me share. Okay, it's not okay. There you go.
Yeah.
Okay, here is the Golondrina that I show you, that point right there from Rio Grande City, just north of Rio Grande City. Here are two Hidalgo points, right? One thing that this poster has that is unique to it, there are several projectile posters out there. Number one, this is unique to the Rio Grande Valley. Every point we know where it came from. And number two, they are to scale. So if you find a point, you can take it to the poster and see how it compares. So here are the Hidalgos. Here is the Golondrina, right? This is potentially a 9 or 10,000 year old this could be 6 to 8. And notice a decrease in point size as you move up the poster, right? By the time you get to the appearance of the bow and arrow, there is no need to make those long, heavy spear points. They are much, much smaller, okay? This poster is going to be, is being printed. It should be here anytime, and we will be happy to send you copies if you request them at no cost, or you can stop by our office.
That would be great.
Yeah, we definitely would be interested in those posters. We have another question. Would you like points from Webb County and Mexico?
From Webb County, as long as you know where they come from, yes. Because, I mean, unless we know exactly where the point came from, it is of no value, right? If we know it came from this area, that will do it. From Mexico, I would be a little hesitant because of, you know, issues with working with cultural, you know, tools and stuff. But anything from any of the South Texas counties, I would be very interested, and I would appreciate if you let us look at them.
There's a question, isn't shirt common in colder, deeper ocean water?
And here,
Oh,
I think that was a
oh, I'm
question.
muted. No, I'm not. Can you tell him? It's in the
I'm
chat.
sorry, can you repeat it? I could barely hear some, you know.
I'm trying to find the question. See it on the chat.
Let me see the chat. I don't.
It's 8:37 p.m.
So when we get this issue resolved on the question, let me ask the audience, and you can just raise your hands there. How many of you were aware of this volcanic ash so close to us and being part of our own landscape? No? You knew. Let's see. Catherine, you knew, right?
Okay, so the question is it shirt common in colder, deeper ocean water?
Yes, it is. Chert forms in two ways. The most common way is it forms on the ocean floor in cold water when biogenic silica, that is silica produced by plankton, you know, from out of seawater, when the organisms die, it settles to the ocean floor, it accumulates, and given the right conditions, it turns into a rock. That's mode number one. Mode number two, it forms by replacement. In massive limestones, when groundwater circulates through limestones, it replaces the carbonate by the silica, and it turns into layers of or randomly shaped pieces of chert, right? Those are the two most common modes of formation. What you hear me say on the El South chert is a completely different mode of formation because it forms on the surface of the planet by groundwater remobilizing silica. So it's none of the two conventional ways of forming chert.
We have a lot of titanium on our camera calculations. Would the titanium in the shirt reflect saltwater exposure?
No, if you are referring to those black sands that you find in places like portions of Boca Chica, there is a mineral there that has a little bit of titanium, not a lot. But there is really no connection to the volcanic ash. That is just from the weathering of rocks on continents, and it brings it. It's the mineral ilmenite, no connection to the ash. But some of those black sands do have titanium. So, Catherine, you were in my class. I'm sorry if I Physical geology or historical geology or? Okay, physical geology, okay. All right, any other comments or questions?
If not, thank you so much,
Yes,
Dr.
Miranda
Gonzalez.
City. This is from, who is writing this?
Oh.
Edward, right? Edward, can you raise your hand so I see you?
Yes, I can't see myself.
Okay, yeah. that outcrop in Miranda City, that's the volcanic ash. Yes, and I've been to it several times.
Mm-hmm.
I don't think we have any more questions. Anybody else? If not, thank you so much, Dr. Gonzalez.
No problem. No, my pleasure. I always enjoy doing this. Sorry about the issue. It worked for the three of us yesterday when we tested. I don't know what happened tonight, but we went through it. So.
Hey, this worked out fine.
Excellent. Happy to hear. Bye, everybody.
Bye. Thank you. Okay, can you guys hear me? Okay.
Yes.
Okay, good. Just a few more housekeeping things. Next week, we've got Dr. Benavides talking about water resources and hydrology. And then Barry Goldsmith from NOAA is going to talk about weather and climate. A little bit about VMS when you're entering things. If you go out on your own and identify birds, that's not, doesn't qualify for volunteer time. But if you're doing bird plant, insect identification, and if it counts as part of a project, for example, Monarch Watch, City Nature Challenge, etc., that does count. So we'll be sharing more about that later, but some have had questions about that. Be sure to RSVP if you want to go to the field trip on February 5th. Your classmate Ed Meza has been generous to give us a pre-opening tour and at the Eco Center in Laguna Vista, and then we're going to go on a Laguna Madre Eco Tour in the afternoon. So, but you have to RSVP for those. More information will be coming about the April 9th Cactus Creek Ranch bird banding and visit to Laguna Ascosa. Oh, that's the last one. So, do you guys have any questions?
Barbara, I have a question. What are we supposed to wear when we start doing our volunteering hours?
If you can't, if you got a name tag, I know no one's gotten shirts yet because I just got them from the person that had them in the storage. So if you have a name tag, wear it. If you don't, just identify yourself as, you know, being with Texas Master Naturalists.
Okay.
Eventually, well, I volunteer at Ramsey and have since 2015. I don't necessarily wear a Texas Master Naturalist shirt or I usually wear a cap that says Texas Master Naturalist. So basically, you want to walk into the place and say, "Hey, I'm here volunteering for Seator Link. I'm with Texas Master Naturalist," and typically places will give you their own name tag and things like that too. But thank you for that question.
Okay, and also part of that, like Rolando said, yeah, you have to fill out an application, a form. So then most of the places that we go to, they're going to require us to also fill out forms also before we can start volunteering there.
Well, I didn't mention that, but I've never filled out anything for Rolando, so I think he didn't care about hurting us. No, I'm being totally facetious about that. But some places, especially Texas Parks and Wildlife, like Resaca de la Palma, place like that, they're going to have you fill out something.
Okay.
And Ramsey Park, Zip, I need to contact Rolando and say, hey, what am I supposed to fill out? Because I've never filled out anything, and I've been volunteering there for several years. So, so the answer is it's all over the place.
Okay, that's fine.
Check with the place you're going to volunteer and find out the.
I just wanted to make sure that I wasn't going to show up somewhere and then like I don't have the proper ID or something that they want. You know, that's what was my concern. So.
Well, it's a good question, and I'm glad you asked. Okay. But I don't think that'll be a problem. And
one thing I will add is that some organizations, like if you volunteered at Laguna Tascosa or one of the other national wildlife refuges, they have certain policies, and you do have to sort of register as a volunteer. You go to some other locations and they recognize you as a Texas Master Naturalist that went through the application process, you went through the background check, and they'll accept that as all the background that they would need. A lot of organizations that are part of Texas Parks and Wildlife will recognize that and say, okay, then I don't need anything else because your name is already registered as a volunteer in the system.
I see. Okay.
But then you have some organizations, some other nonprofits, the Birding Center, we work with them all. They know us, they know the program. Many of them that run the Birding Center are master naturalists. And so they'll simply accept that as, okay, I know the training that you went through, the application process that you went through, we don't need anything else.
Oh, okay.
And your classmate, Remy Vargas, can vouch for you because he works at the Birding Center.
He does?
Yes, he does.
Oh, okay.
He's new, but relatively new.
Well, because that's one of the places that I want to go to. I talked to Javi about it already, so he said that was fine, but haven't had a chance to start yet. And the weather, it's been not good. So.
Right. Yeah.
Plus,
absolutely.
I mean, I work, so I don't have the week, you know, it has to be either Saturday or Sunday, and that's if I'm not having to do teaching stuff on a Saturday. So really, I'm very limited. But I mean, once I have spring break and summer, well, then I'll have plenty of more time to do stuff. But right now, during the work week, it's not viable for me, like during the day.
A lot of the times we'll get from Javi, and of course we'll get from Remy, any special projects that they have, any work that they're doing. Last year's class, we had 5 or 6 that were out there cleaning out the sediment, and it was muddy, yucky, but it was fun. I mean, you get to do some really fun stuff out there with the Birding Center.
So then, like, if you volunteer, like, you have to work it out with, like, say I go to the Birding Center and then I say, oh, well, I'm here to volunteer. I can't just show up and say, I'm going to volunteer. They have to give me the day that they want me to go and the hours they want me to work. Is that how it works? Or do you just show up and say, oh, I'm here. What do you need me to do? That's what I don't know.
I think maybe Remy can add something to that as an example for us.
Yeah, so usually Javi will take care of that volunteer schedule. So we don't have too many volunteers at one time. So usually Javi is the one in charge of all the volunteers.
Okay.
So if you want to get with Javi to volunteer certain days, he'll probably work with your schedule.
Okay, yeah, because, like, I mean, that's what was my thing. Like, yeah, they may need us on maybe a Tuesday or a Wednesday, but like I work, there's no way I can go on those days, you know. So, I mean, I could make myself available just on weekends. Oh,
Yeah, if you want, I could give you Javi's email and just shoot him an email or text and.
I have his
have
phone number. Yeah,
Oh, okay.
I mean, I have his number. But
Yeah.
I just wasn't sure like how that worked, you know, like I mean, you know, it's just since we're all new to, well, I'm new to this. I just didn't know like, hey, I'm here, it's 9 o'clock in the morning, put me to work, you know, so.
And this is a really good question and good time for this to come up, because you all should have been contacted by, or you all were assigned a mentor.
Yes, we have a mentor.
And that's a good question to work with your mentor on, because, you know, helping you find, like, I mean, you know, Javi, you know his phone number, but in many cases, you all don't know places, how to contact, who to contact at a place, but you
Right.
always want to save your own time, and is to reach out in advance and find out when they need people. Because like
Right.
you said, it's not just necessarily you walk in and
Yeah.
then say, oh, sure, go
So-
do this.
Right. So like if I go to Resaca de la Palma State Park here in Brownsville, because it's, you know, it's in Brownsville and I live in Brownsville. So I would just go introduce myself, tell them I'm in the program, and then I guess then they help you, like they tell you what days you could come in and work or something like that.
Or we can, you know, give you some contact information. If you, to save your time, I think it's better to email,
Call them or email
call,
them.
you know,
Okay.
just so
Sure.
you know you know that you're talking to the person you need to talk to,
Right.
and that you have an appointment to talk to them.
Okay. That's very helpful.
That would be
Thank
my
you.
suggestion.
Yes, thank you so much. That's very
Mhm.
helpful.
And just like we have a work day at Ramsey every Thursday morning.
Yeah.
And so, like, people, there is no place to just show up and talk to someone.
Yes,
You know,
right.
if anybody wants to find out about opportunities at Ramsey and that type of thing, reach out to me and I can help you figure out when somebody could be there to show you what to do. And other than, we work Thursday morning, and some of the people from ACUS work on another day of the week. So
Yeah, because like I'm off on Saturday, so I could go to Hugh Ramsey Park and there's nobody there. So you know, what would I do? I wouldn't.
right, exactly. So that's exactly where your mentor and Robert and I are here to point you in the right directions.
Okay.
And I think that Penny,
Barbara,
who's on here
would-
with Bobby, has a project, and we were talking about it a little bit at the beginning, that Rio Hondo has a boat ramp and they're going to be working with some native plants and things. And keep in mind, Penny, you got people that want to work on weekends.
Now, speaking of boat, you just mentioned, okay, next week is it's a boat tour of the Laguna Madre. Like where are they taking us exactly, or where is, I mean, do you, like, where do you meet up and where are we going? Is that available yet or not yet?
Well, what we're waiting for is a final head count of who can make it, so that we can then go ahead and finalize those details, and we'll let everybody know.
Okay. But I mean, would that be on the bay side or the beach or the jetty side? Like where would you be going?
It would be on the bay side.
On the bay side,
Yeah.
okay.
Barbara, you have a question? What time Thursday morning at Ramsey?
Oh, 9 o'clock.
We also have an
Who asked the
ongoing.
question?
Sorry,
Who asked it?
Yvette.
Oh, Yvette. If you're interested, in Ramsey, either I or my co-chair sends out email, and like in the morning, if it's pouring down rain, I'm going to text everybody and say, hey, we're not going to be there. So I'll add you, Yvette, to that.
We also have the project that we're working on at the coastal fisheries station in Brownsville. We nicknamed that Fish Trails, and we're trying to open up the paths around the ponds that are there. And it's turned out to be pretty challenging to try to fight back on the Brazilian pepper that has moved in. So that's another opportunity that we'll share a little bit more. Maybe next week, Laura, we can share a little bit more about the project that you'll spearhead for SPI. And so there's all these different opportunities beyond what you might think of a building like the SPI Birding Center or a park like Resaca de la Palma. So there's other opportunities as well that offer us a whole lot more flexibility. Once you know what to do, then you can go in there whenever you got free time, knowing that, okay, this is how I can identify a Brazilian pepper, and we don't like Brazilian pepper, so we cut it out. In other cases, it's just tending a garden. If we got new plants in a garden, then we want to make sure that we pull out the weeds, we water and take care of them until they get themselves established. So there's a lot of things that we'll go over regarding other opportunities too to fit your schedule.
Like that place at the island, Sheep's Head. Do you all do stuff at Sheep's Head or not?
Can I add something?
Yeah, go ahead.
The lot at Sheep's Head on the island is owned by the Valley Land Fund. Our chapter meeting on Tuesday, the 8th of February, the executive director of the Valley Land Fund is our presenter. And that is one of the projects that she really wants to get volunteers for, is maintaining Sheep's Head. Glad you asked that.
So you're going to send us information on that one for the meeting
Absolutely.
and stuff? Okay.
We're going to send you information about the meeting. It'll be it's virtual and in person. It's in person at the library in Harlingen on Tuesday evening, the 8th, and then it's also virtual. But we'll send you information.
Perfect.
Yes.
Okay. Thank you.
If nobody has any other urgent, pressing questions, it's 9:01. I know it's
Thank you.
It's past my bedtime. No, I saw that Rolando said it was past his bedtime.
Good night, everybody.
Okay, thank you. Good night.
Thank you.
Before you go,
Good
I just had a
night.
question regarding the volunteer stuff.
Good night. Thank you.
Good night.
Or the field trips. Do we need a high profile vehicle to access any of these locations, a pickup truck or anything like that, or are they accessible in a car?
For the field trips that we're planning, they're accessible by a car. The trip to the Eco Center, if you haven't driven by there, it's it has its parking lot, no problems. Some of the things that we will investigate regarding Laguna Tascosa, we may want to rent a vehicle like a passenger van to make sure that we can get to some of those sites. Some of the roads are closed, so we're checking to see what kind of permits we need to complete so that we can get our own tour of a closed road. So we're still exploring some of those things, but some of these we will not ask you to make sure that you have a fork-wheel drive or anything else. But like if you were to volunteer with Sea Turtle Inc. and you want to help with like for example, we just recently had the Colston Sea Turtle Patrol. They asked folks if you can go out there and help us look for Colston sea turtles. Some of those places, like getting to Boca Chica, you would need a fork-wheel drive to get out there. And so when they know that they're stranded out there in that part of the bay, then they're asking for folks with a fork-wheel drive that can get out to the turtles to help rescue them. So you might find opportunities where if you happen to have a fork-wheel drive truck that can get you there, then you definitely become somebody they want to talk to. Other groups will do a beach cleanup up the north side of South Padre Island. And some of those places, it's great to have a fork-wheel drive too. And so you might be asked, hey, if you can volunteer, you might help shuttle some of the folks up to some of those areas because there's no way their car could make it. So if you have something like that, you might find groups asking for your help, especially because if you do have a vehicle like that. But most of the field trips we're planning, we're not going to ask you to or risk losing
The beach cleanup counts as volunteer hours, because I know I heard somebody mentioning that they were having a beach cleanup like really soon, like this month or next month or something.
On Facebook, if you have access to it, if you don't, let me know and I'll send you the email. There is a group that's coordinating a beach cleanup on where the Highway 100 ends north of the city.
Right, yes.
So those beach cleanups do qualify for volunteer time.
Okay,
I think we also mentioned that there's also a category that we have in BMS, which is called Pick Up the Valley. If you decide that you're going to, Michelle, I think you go to Olivera Park. If you
Right.
decide that you want to go out there and spend an hour picking up trash or any of your neighborhood parks, then you can log that time to pick up the valley within BMS, because we do want to
Really?
encourage everybody going out there and picking up trash where you see it.
Oh,
If you
well,
go-
that would be, I could do that too. That would be great. I get
And so,
credit for it.
and that also applies if you want to go to the beach and pick up a bag of trash, even
Yes.
though it's just by yourself, you can still log it to pick up the valley.
Okay.
That's one that they added during COVID because there weren't a lot of opportunities. And it's actually, it falls completely within our scope of, environmental, it doesn't mean just the beach needs trash picked up, anywhere does. So I'm
Okay,
glad.
so if I go to the park for an hour, like, I don't have to tell anybody, then I just do it and then I put it on the logbook or something?
Yes.
Oh,
Your
wow,
volunteer time, we don't put a tracker on you.
yeah.
And, it's completely honor system.
Hey,
Yeah.
wait a minute. Javi does put a tracker on them, so
Yeah, Javi may, but.
yeah.
Okay, that sounds good. That sounds good. At least now I know that, because yeah, I like to go out there so okay. Can do that.
We have the red crown parrot count, I think, next week also, that they can get hours for.
Yeah,
Yes.
I emailed Barbara. I got your email and I went ahead and sent an email to the man in charge of the Brownsville area to let him know I'm available for Brownsville if he needs my help or if I can do it. So
Great.
And if we get his phone number, then we'll pass it along too.
perfect. Thank you.
Great.
All right.
Well,
Thank
hope
you
you
all.
guys,
Hey,
hope you
but
guys like the speakers tonight.
one last thing. If you do go do some of those things, take pictures. Send them to me or put them up on Facebook. We want to make sure that everybody can see what everybody else is doing, because if you guys are out there, I mean, that's great encouragement for everybody else to do that too.
Okay, that sounds great. Thank you. Well,
All righty.
all right.
Thank
Good
you,
night,
everyone.
everybody.
Good night.
Good night. Thank you guys. Hope you like the speakers.